What's up to you all beautiful and awesome pre-matriculants? Welcome to it. This is your favorite show where you learn more and learn extra with us. My name is Abram and welcome on the new slot. It's a promotion for you guys because this is a grade 12 slot. So we believe in you guys. Make us proud. My name is Abram and we have our teacher, Mr. Lunga Gunjan Baba. Nami Nyapila, are you ready to teach?
Yes, I'm ready.
Because the nation is ready to learn. What are we doing with the grade 11s?
Okay, today we're going to look at paper 2. So it's going to be trigonometry, geometry, and analytical geometry.
Are you amped? Are you okay?
Yes, yeah, I'm fired up. I'm ready.
Are you ready?
I'm ready.
Because I'm ready. It seems like I'm more, the mindset is, and I am more ready. But I guess, guys, you need to get your notes for you to be ready. We have the notes. That's why Lunga is ready, because he has the notes. If you need all the notes, go to land.mindset.co.za. Otherwise, chat to me, send me your questions or suggestions and your comments on facebook.com/learnextra. Plus, we've got some awesome giveaways for you guys. Safeway is K53, you should be knowing by now. I'll tell you more during the show. Lunga, over to you, sir.
Super. Right, grade 11s. Let's take a quick look at what we're going to be covering today. All right, so as you can see in this lesson, we'll be looking at analytical geometry, trigonometry, and Euclidean geometry, which are a huge chunk of your paper 2 upcoming exams. Right, so let's take a look at our challenge question. This is the question I'd like you to try at home, and then we'll look at it at the end of the session. And I believe you can post your answers on our Facebook page as well. Is that right, AB?
That's correct.
Super. Okay, so what does the challenge question say? Right, it says determine the general solution. Okay, so you should take note of that. And the square root of tan theta is equal to x plus 1 over x, but they do give you a hint. Okay, they say that x squared plus 1 over x squared is equal to 1, so you need to determine the solution. In other words, they want you to tell them what the value of theta is equal to. You must tell us what theta is equal to, the general solution though. So please take this down and start working on it, and then we'll post those answers on Facebook. AB cannot wait to see your answers. Right, so let's look at what we're going to do in this session. Right, question 1 here is taken from an Eastern Cape paper. Okay, it looks like an analytical geometry question. Right, it says determine 1.1.1 the values of K and P. Right, so now remember, with analytical geometry or Euclidean geometry or even trig, if you're given a sketch, it is your sketch, it is your question paper or your exercise book. Feel free to make notes, to draw lines and highlight things on your sketch. That's what we're going to do in this case, because if you find the solution to an answer and you draw it on your sketch, it'll actually help you with the next question and so on. Right, so what do we have here? They want us to determine the values of K and P. Right, so what is K and P? K and P are the coordinates of point F. Right, so K will be our x coordinate and P will be our y coordinate. Right, so what do we have? We can see that this line AF has been divided into 2 equal parts. All right, the midpoint of the line is B there. Right, so if you want to work out K and P, we know that if you think of the midpoint theorem, how do you work out the midpoint of a line? We take the x values, the x coordinates, add them together and divide by 2. And to get the y coordinates of the midpoint, you take the y coordinates, add them together and divide by 2. So we're going to use that theorem in this case. Right, so we know that K plus the x coordinate of A, so it's plus minus 4, divided by 2 should give me negative 1. That's the midpoint, okay? And that's a beautiful equation. Let's see if we can solve for K. If I multiply both sides by 2, I'll have K plus negative 4 is equal to negative 2. Okay, let's sort out these signs here. This means that K minus 4 is equal to negative 2. And solving for K means that K is equal to minus 2 plus 4, which is going to be equal to 2. So the 2 is done. So I can write in my 2 there. in order to work out P, we know that P plus the y coordinate of A, so P plus 1, divide those by 2, should give you the midpoint, the y coordinate of the midpoint, which is negative 2. Negative 2. Right? So multiplying both sides by 2 again, we have P plus 1 is equal to negative 4, which means that P is equal to negative 5. And there we've solved for K and P, which means we can go back to our sketch and fill in the stuff we've worked out. This is going to be 5, and this point here is 2, 5. Awesome stuff. Let's look at the next bit, 1.1.2. They say work out the gradient of AF. Now this is very easy grade 9 work, working out the gradient of a straight line. It's a change in y values over the change in x values. So the gradient of AF is equal to, right, so, sorry, I need to go back so I can see my points. It's 2, 5 and negative 4, 1. So let me just make a note here, negative 4, 1. And my P is going to be 2, 5. Sorry, 2, negative 5. 2, negative 5. Right, so the gradient, change in y's, minus 5, minus 1 over 2 minus negative 4. Allow me to make that a plus 4. So this means that the gradient is negative 6 divided by positive 6, which is negative 1. That's 1.1.2 done. Moving right along. 1.1.3. Now they say they want you to work out the equation, note the equation, of the perpendicular bisector. Perpendicular means the two lines meet at 90 degrees, and bisector is another important point there. Bisector means it cuts the line in half, cuts it in 2 equal bits. The perpendicular bisector of AF. Let's just go back to our sketch quickly and sketch in this AF. So the perpendicular bisector of AF will be a line going like that. And that is at 90 degrees. They want the equation. What do you know about perpendicular lines? The gradients of perpendicular lines. If you multiply them together, you get an answer of negative 1. And if you're given the gradient of one line, and you want to work out the gradient of a line perpendicular to it, all you do is you tip it, reciprocate it, and change the sign. Again, grade 9 work. Right, so if the gradient of AF, which we worked out earlier, is negative 1, if I want to work out the gradient of the perpendicular bisector, it means that the gradient will be, you change, so you reciprocate it, it'll still be negative 1, but if you change the sign, it's going to be positive 1. All right? So I know that, since it's a straight line, I know that the equation will be y is equal to 1x plus something, okay, the y-intercept. Okay, so now in order to work out the c value, I can substitute a point, because I hope you agree with me that if I have a value of y and a value of x, I can then solve for c. Okay, so the gradient is done. So what point shall we substitute? Let's substitute the point at which the two lines meet, which is negative 1, negative 2. Right, so go back to my equation. So instead of y, I'll now put in a negative 2, and instead of x, I will have a negative 1 plus c. Okay, and what does that mean? It means that negative 2 is equal to negative 1 plus c, and solving for c, I'll have negative 2 plus 1, which is negative 1. Okay, I've got a gradient, and I've got a y-intercept, which means I can put down the equation. It means that y is equal to 1x, or just x, minus 1. That is the equation of the perpendicular bisector. Okay, moving right along. We now move on to question 1.2. It's based on the same sketch, the same triangle. They say, determine whether triangle CAF is equilateral, isosceles, or scalene. You cannot answer this question if you don't know what these words mean. Equilateral meaning all three sides have the same length. isosceles, meaning only two sides of the same length, and scalene, meaning they're all different lengths. Show all working. Right. So let's first work out, the order doesn't matter, yeah? Let's first work out the length of side AC of the triangle. Okay, so A is -4, 1. Okay, and C, we said is going to be 2. Is it 5? Yes, 2, 5. Right. So meaning that the length of AC then will be equal to, in order to work out the distance or the length of a line, we use a distance formula. Thus, formula will be on your question papers at the back, I hope, in most cases. If not, make sure you know it anyway. Right, so it's a change in the x values. So that means -4 minus 2 all squared plus the change in the y value. So that's 1 minus 5 all squared. Okay, so now it's just a matter of simplifying that. So that's going to be -6 squared plus -4 all squared, and it's all under the root sign. Okay, so that's 36 plus 16, which is going to be the square root of 52. Okay, that's the length of AC. Let's look at another side. Okay, bear in mind that F, we said, is going to be 2, -5. Okay, so it means that, let's work out the length of AF now. Okay, might not have enough space here, so I'm going to squeeze it in on the right here. Okay. Okay, but I'm going to squeeze in the 1.2 here. Right, so we're working out AF now. Right, so AF, sorry, let's fix that. It's AF. So the length of AF. Again, it's a big square root sign. And what are the coordinates? -4, 1, and 2, -5. So it's a change in the x values. So it's going to be -4 minus 2 all squared plus the change in the y values, which is 1 minus -5. So it's 1 plus 5 all squared. And this means that this is going to be -6 all squared again plus +6 all squared, which is the square root of 36 plus 36, which is the square root of 72. Okay, so we know what AC is, we know what AF is. We're now left with the last side, which is going to be CF. Okay, I'm going to get rid of this AC now. Actually, no, I won't. I'll squeeze it in here on the left-hand side. Sorry for the messy work. So AF, or CF, change in the x values, -4, no, that's not C. So it's 2 minus 2 all squared. Allow me to write it here below, plus 5 minus -5, so it's 5 plus 5 all squared, and this is all under the root sign. So 2 minus 2 is 0, so it's a square root of 0 plus 5 squared, so it's 10 squared. Okay, so it's a square root of 100, which is equal to 10. Now we've got the lengths of our three sides. One is 10, one is square root of 72, and one is a square root of 52. This means that all the three sides are different lengths, so it is definitely a scalene triangle. So our answer would be scalene because all three sides are different lengths. Scalene triangle. Okay, moving right along to 1.3. They say determine the value of theta and hence of angle AFC. Let's go back to our sketch quickly and see where theta is. Okay, theta is actually that angle there. It's this angle here. That's theta. All right? So we know that tan of the inclination, and inclination is the angle that a line makes with the positive direction of the x-axis. So in this case, it's theta, is equal to the gradient of the line. We know the gradient of the line. We worked it out earlier. It's equal to -1. So if we want to work out what theta is, we can simply say tan of theta is equal to -1. We know the ratio. We want to work out the angle. And how do we do that again? We go to our calculators, and we're going to go shift tan and -1 in our bracket, and it gives us a value of -45. Let's check if that's right. Did we use the correct value of the gradient there? -1, yes, it is. All right, so if that's the case, it means that my theta then is equal to -45 degrees. Okay, grade 11s, we're forced to take a quick break, and we'll come back and finish this question off after the break. AB?
Thank you so much, Lunga. Guys, if you have some questions, make sure that you send them and do the challenge question. We'll see you after this break. Welcome back, pre-matriculants. Now, awesome news are we are running this competition, which is called Be a Bright Spark. If you think you are a bright spark, all you need to do is to buy yourself this official Safeways K53 Learners and Drivers Manual, or download the cool Android app, which is available from Google Play. Secondly, like our Facebook page, facebook.com/learnextra, as well as Safeways K53, facebook.com/Safeways K53 page. Lastly, the third thing you need to do is to fill in an entry form available from our Facebook page. It is on a tab called Win a Chevy Spark L. So you could be a winner of one of the 4 Chevy Sparks that we're giving away. Guys, remember the closing date is the 15th of November, and the winner will be announced live right here on Learn Extra Sunday, 23rd November. So you could be driving that Chevy, get your marks, all right, and get a car. So that will be nice. It will be a great bonus for you to enjoy the holidays. Lunga, over to you.
Thank you, AB. So let's just finish that question off. Right, so if this angle here, if this entire angle here is equal to 135 degrees, and in our question we're told that this line here is parallel to this one, so it means that if that whole angle is 135 degrees, this angle here must then be equal to that angle, which is theta. Okay, so in order to work out this angle here then, the answer is going to be 135 minus 90. Okay, so 135 minus 90 is actually equal to 135 degrees minus 90 is actually equal to 45 degrees. Okay, which then is my value of theta. Okay, that's how big that small angle is. Let's move right along to the next question. We come across question 2 here. And it looks like an identity, a huge chunk again of trigonometry. They say simplify without using a calculator, all right? So you should not, your answer will probably not have decimals or anything like that here. And what are we given? We are given sine 117 divided by cos 27 plus cos of negative x, multiply, this dot means multiply, tan 180 minus x, multiply by sine 360 degrees plus x. Right, so since we're not going to be using a calculator, we'll probably use special angles and reduction formulae. Right, so let's take it away. Sine 117, okay? That is in our second quadrant, which means that the reduction formula to use there is 180 minus. So it's going to be 180 degrees minus 63 degrees. because 180 minus 63 is 117. Okay, and this is all over, again, cos, right? I need to use something that's similar to 63, because at the end of the day, certain things should divide each other out. So another 27 is actually equal to 90 degrees minus 63 degrees. Okay, so I'm done with that first part. Plus cos of negative x. Negative x is in quadrant 4. All right, so we're looking at that quadrant there, and everything in quadrant 4, well, cos is positive in quadrant 4, so I can simply write that as positive cos x, okay, and I've got 10, 180 minus x, 180 minus is in the second quadrant, and 10 is negative there, so I need to multiply it by negative 10 x, and 360 plus x is in the first quadrant, so that's going to be positive sine x, because everything, all three ratios are positive in the first quadrant. Okay, let's move right along. Okay, applying our reduction formula, that's going to be sine 63 degrees over, okay, you need to be careful with this one, this is a co-function, so what does it do? It changes from cosine to sine, so it's going to be sine 63 degrees, okay, and I've got a negative sign there. Let's do the different color. Oops, it's a negative, all right, so it's going to change this negative here, so it's going to be minus cos x times, I'm going to write 10 as sine x over cos x. That's what you should try to apply. Times sine x. Right. So this works out beautifully because it's going to be equal to 1. And if I look at the second bit, that bit there divides that one. So I'm going to be left with minus sine squared x. Right, now if you think back to grade 10, when you started doing these things, there's that famous trigonometric identity. We know that sine squared theta plus cos squared theta is equal to 1. So this means that 1 minus sine squared theta is equal to cos squared theta, or cos squared x. And that is, my answer is nothing more I can do to that. So the answer to that question is cos squared x. Let's look at the next bit. We're moving on to question 2.2. Again, they give us that identity. We now need to prove that the left-hand side is equal to the right-hand side there. So all you need to do is to take the left-hand side and play around with it until it looks like the right-hand side, or the other way around. In that case, you will have proven that the identity is indeed true. So it looks like more work needs to be done on the left-hand side here. There's nothing much to do on the right-hand side. So let's play with the left-hand side. My left-hand side is going to be equal to cos x over 1 minus sine x, subtract cos x divided by 1 plus sine x. It's an s, not an 8. Right, so what I'm doing here is I'm subtracting one fraction from another. So very easy primary school work. How do we subtract fractions? We find an LCD. So my LCD is going to be 1 minus sine x multiplied by 1 plus sine x. Right? So this means I need to multiply that numerator by 1 plus sine x, as you would add or subtract fractions. There is nothing new there. Okay, minus cos x, and that cos x needs to be multiplied by 1 minus sine x. Okay, let's just extend that line a bit. We're just going to try and simplify this now. Right, so if you look at the numerator, there is a common factor there of cos x. So I'm going to take that out because I'm simplifying here and hope that that common factor will divide with something in the denominator. Right, so my highest common factor is cos x. Okay, open bracket. What's left over from the first term? We're left with 1 plus sine x. Okay, so we're left with that bracket. Take away, or minus 1 minus sine x. Right. And the denominator, if I simplify that, it's 1 minus sine squared x. Okay, that's the difference of squares, and it looks familiar. It looks like something we did in the previous question. Right, so we can now say that cos x, and let me simplify what's in the big bracket. It's 1 plus sine x, distribute a negative 1 in there, minus 1 plus sine x, close bracket, all over that famous identity again, cos squared x, right? Okay, I'm going to squeeze stuff in here. So this will be divided by one of these, which means I'll be left with cos x as my denominator, right? And if I add like terms in the big bracket, 1 minus 1 is going to be 0, and I'm going to be left with a sine x plus sine x, so that's 2 sine x, all over cos x. And sine x over cos x is actually equal to tan x. So this means that it is equal to 2 multiplied by tan x. And as you can see, this is equal to my right-hand side. So we've proved that identity. Let's look at the next bit, 2.2.2. It says, if x is an element, or if x belongs to this interval here, negative 180 to positive 180, give two values of x for which the identity is undefined. Right, so if you're thinking trigonometry and trig graphs and something is undefined, you should be thinking, hopefully, the tan graph, because the cos graph is continuous and so is the sine. It just flows beautifully on and on forever. However, the tan graph has asymptotes. So there are points where the graph is undefined. There is no value of the graph for certain x values. Okay, and we all know that that happens at 90, it happens at 270, and if you look at the negative side, it happens at negative 90 and negative 270. But we are given an interval here, so it's restricted to this interval here. So the two asymptotes that fall into that interval are negative 90 degrees and positive 90 degrees, because the other two, the 270s, are outside the interval. So this means that the two x values are going to be x is equal to negative 90 degrees, that's why we have an asymptote, and x is equal to positive 90 degrees, that's why we have the other asymptote. Two easy marks. Okay, we're moving right along to question 3. It says the diagram below shows the sketch graphs of f of x is equal to a cos bx, and we're also given a graph for g of x. And we're also given an interval, all right, which means that that value there should be negative 90, and then the one right on the end here should be positive 180 degrees. Right, so let's look at what they want us to answer then. 3.1, write down the values of A, B, P, and R. Okay, so if you go back to our sketch, we should have some values here, okay, on my sketch, although they have not been put in here, but I can find those out for you just now. So what I'm going to do is I'm going to move on to the next question, and then perhaps after an ad break I'll come back to this one once I have the values that go on the x coordinate. All right, so let's skip this for now and we'll come back to it in a few minutes. Let's look at question 4. And it looks like a Euclidean geometry question. Right, it says in the diagram below, AB is a chord of a circle with center O, it says D is a point on the circle. So my D is down here. So it's that point there. OD is perpendicular to AB. OA is 25 and CD is 18. So let's just put all this stuff in. Remember what I said earlier. Put all the information you know onto your sketch. It'll make your life much easier. Right. So I know that O is the center. Okay, so if O is the center, it means that this line and that line, OA and OB, are the radii of my circle. And so is OD. All right? And what do they tell me? They say that OD is perpendicular, so that's that 90-degree angle there, to AB. OA is 25, so this is 25 centimeters. And CD, so this bit here is 18 centimeters. All right. But if OA is equal to 25, so is OB. That might also be equal to 25. And so must the total length of OD. That must also be equal to 25. Okay? So we can automatically see that OC, that point there, should then be 25 minus 18, which will give me that bit. Okay? Anyway, let's see what they want us to work out. They want us to work out, for 5 marks, the length of AB. Okay? So AB is that chord there. Right. Okay, so we need to give reasons all the time with geometry. Okay, so we know that OA is equal to OB, and they are both equal to 25 centimeters. And the reason will be they are the radii of a circle. All right? And OD is also equal to 25 centimeters. And the reason is it's a radius. Okay. So it means, therefore, that OC will be equal to OD minus CD. So it's going to be equal to 25 centimeters minus 18 centimeters, which is equal to 7 centimeters. So let's go back to our sketch and fill that in. So this bit here is 7 centimeters. Right? So how does that help us? I want to work out the total length AB. Okay? We can then use Pythagoras to work out AC, because I know the hypotenuse and I know that vertical side. So if I use Pythagoras, it means that AC squared is equal to 25 squared plus 7 squared. Okay, so then if I work that out on my calculator, 25 squared plus 7 squared will give me 674. So AC squared is equal to 674. So that means that if I want to find the square root of that now, okay, so square root of 674, I get an answer of 25,9. Let's check, did it do everything right there? 25,9, and that is my length of AC. Okay, but if that's my length of AC and I want to work out AB, do you agree with me that AB is equal to 2 times AC? Why? Because if you look at these two triangles, OAC and OBC, they're actually congruent to each other, because there is a side, they have a common side, and those two sides are also equal, and they've got 2 angles that are equal to each other. So it means that the 2 triangles are congruent. So we can say that AB then is equal to 2 times AC, all right, which is going to be 2 multiplied by 25,9, okay, and which is going to give me an answer of 50,18 centimeters. And the reason will be triangles are congruent. So it's going to be triangle OAC and OBC. Triangle OAC is congruent to triangle OBC, and that is the length of my AB. Right. Let's look at the next bit quickly. Again, it's a Euclidean geometry question. In the diagram below, they say QOB is the diameter of the circle with center O. PR is parallel to QB, so there's PR parallel to QB, and they say that QB is perpendicular to RS, as you can see there, and PBQ, so that's an angle, PBQ is actually equal to 25 degrees, so that's that bit there. So that's equal to 25 degrees. P, R, and S are points on the circle. So I'd like you to take that question down, okay, and try and work through it in the ad break, and then afterwards we'll tackle that one. AB?
Thank you, sir. And after the break, we'll also be doing the right answer for the challenge question, because the mindsetters are saying, yo, this is a very difficult challenge question. I bet it's just challenging, guy. It's not really difficult. It's challenging, it's doable, and it's for you. We'll see you after the break. Welcome back, my sisters. You just saw Luni and I talking about the Be a Bright Spark competition. Guys, I can't stress it. I want you to win one of these 4 cars. It should be yours. Don't you think? If you think so, go get yourself this official Safeways KP3 Learners and Drivers Manual, or download the cool Android app. More information is on our Facebook page, and do like the Safeways KP3 page as well. Guys, make sure that you enter, because on the 15th, it's the deadline. We're closing. And on the 23rd, we'll be announcing the winner, the owner of the new Chevy Spark L. It could be yours. Now, back to Matt.
Thank you, AB. Let's then continue with this question, 4.2.1. Right, it says determine now with reasons 3 other angles that are also equal to 25 degrees. Right, let's go back to our sketch. Okay, as you can see, they've got parallel lines, and that means something. It means you should be thinking corresponding, alternate, and co-interior, perhaps. But let's see what we're given. All right. So they tell us that that angle there, which is what's the name of the angle again? PBQ. So it's this angle here is equal to 25 degrees. If those 2 lines are parallel to each other, it means that this angle here must then be equal to that one, and the reason would be alternate angles, wouldn't it? All right, so that's our first angle. We can say angle R PB is equal to 25 degrees, and the reason would be alternate angles. Okay, why? Because PR is parallel to QB. Okay, what else can we say? We can, so that's 25 degrees. Let's write that in. Okay, and a very important theorem, as you can see here, that these 2 angles, meaning that angle there and that angle there, are subtended by the same arc, RB. So it means they must be equal to each other. So there's our second angle there, 25 degrees. Let's write it down. It's angle RQB. Angle RQB is also equal to 25 degrees, and the reason would be angles subtended by same arc. And what is the name of the arc? It's PB. PB. Okay, we need one more angle that is also equal to 25 degrees. If we look at our alternate angles again, but the other way now, so that's my N or my Z, if I think of it, if we think of it in terms of grade 9 and 10, so grade 8 and 9, so it means that this angle here is also equal to that. What is that angle? PRQ. Angle PRQ is also equal to 25 degrees, and the reason will be alternate angles. PR is parallel to QB, and that's an easy 6 marks. Okay, moving right along. What else do they tell us? Okay, they say in the diagram below, Okay, so we've read through that. Let's look at question 4.2.2. Determine with reasons now those three angles, ROB, ORT, etc. Okay, let's just fill in what we know. We know that that's 25. We know that this angle here is equal to 25 degrees. We know that that angle there is 25 degrees. And we know that this angle here is also equal to 25 degrees. Right, so we now need to work out ROB. Where's our ROB? So they want us to work out, let's change colors. ROB is this angle here. Okay, how big is that angle there? Right, ROB is an angle at the center of the circle. All right, so perhaps we need to use the theorem here that says that the angle at the center of a circle is twice the angle at the circumference. Is there an angle that is subtended by the same arc as ROB? Yes. So if you look at arc RB, it subtends this angle here in green, and it also subtends that one there. Okay, so it means that ROB is equal to twice the angle up there. So ROB is equal to twice the 25 degrees, which is equal to 50 degrees. Okay, and the reason would be angle at center is equal to twice the angle at the circumference. So this guy here is equal to 50. Right. ORT, where would that one be? Okay, ORT, let's use a different color there. How about blue? ORT would be that angle there. They want to know how big it is. And I hope the answer has just jumped out at you. That is a right-angled triangle. Okay, that's 90 degrees, that's 50, and we can easily work out ORT. ORT is therefore going to be equal to 180 minus 90 minus 50, which means that is equal to 40 degrees. Okay, and the reason would be sum of angles in a triangle. All right, and let's look at ROS. Okay, so let me fill this in. Remember to fill it in. This is 40. ROS, where is that? So it's ROS. Okay, so it's these two together. Okay, right. If you look at the triangle ROT, so if you look at this angle, so this triangle here, ROT, and look at this angle here, sorry, this triangle here, OTS, you can see that they are actually congruent to each other because they share that side and they've got the two 90 degrees which are equal to each other and the two radii. Okay, so they've got two sides which are equal to each other, which are the radii. There is that common side and there is a 90 degrees. So there are three things equal to each other there. So it means that the two triangles are congruent. So that means then that SOT must also be equal to 50 degrees. And the reason would be the congruency. The two triangles are congruent to each other. So if this is equal to 50 degrees, grade 11s, it means that the two angles together should add up to 100. So ROS is equal to 50 plus 50, which is 100 degrees. Right, the last bit. And they say RPQ, where is that angle? RPQ, so that would be, let's use purple, RPQ would be this angle here. They also want to know what that angle there is equal to. Right, we know that that bit is 25, so we need to worry ourselves about the other part of that big angle. Right, if you look at triangle PQB, okay, I'm just going to use a different color here. Let's use that green there. Okay, so if you look at this triangle here, you can see that it goes through the center of the circle. Okay, so QB is actually the hypotenuse of triangle PQB. So it means that this angle here, ladies and gentlemen, should be equal to 90 degrees. All right, and the reason is it's an angle in a semicircle. So that is QPB. QPB is equal to 90 degrees, and your reason would be angle in a semicircle. Right, so if that is equal to 90 degrees, and if I want the whole angle, meaning I must add both of them together, it's going to be 90 plus 25. So therefore, angle RPQ is equal to 90 degrees plus 25 degrees, which is equal to 115 degrees. Right, and that brings us to the end of that bit. I would like us to go back to our challenge question and see how many of you have gotten that right. Okay, let's go back to the top. Okay, here's our challenge question here. It says, determine the general solution of tan theta is equal to x plus 1 over x if you are given that. Right, so let's take it away. We need to work out what theta is equal to, okay? So the first step to do that is to work out what tan theta is equal to. And if you know what tan theta is equal to, you can then work out what theta is equal to. So step number one is get rid of the square root sign. And how do I do that? I square both sides. So we have, let's square that, and let's square that, all right? And as soon as we see this bit, x squared plus 1 over x squared, we're going to replace it with 1. And that should get rid of our x's, and it should make our lives much easier. So let's take it away. So if I square the left-hand side, it means that tan theta is equal to the right-hand side. So it means I've got 2 of those. I'm just going to write them both out. X plus 1 over x. So it means that tan theta is equal to, let's fold this out, x squared plus x over x plus x over x plus 1 over x squared. Right. I can already see the x squared plus 1 over x squared. All right, so it means that tan theta, okay, if we change the order of these terms, we have x squared, and if I write that last term second, it's 1 over x squared, and I'm now left with these two. It's going to be 1 and another 1. All right, and what do we have here? We've got x squared plus 1 over x squared, which is what I've got in the orange box there. So I know that this stuff in purple is actually equal to 1, so I can replace it with 1. Right, so let's go back to that color. Tan theta is actually equal to 1 plus 1 plus 1. So tan theta is equal to 3. All right, so now we know what tan theta is equal to. This would be easy. To continue from here, we're given the ratio. We want to work out the angle, so up comes our calculators. We need to go shift tan 3. And it gives you 71.57 degrees. So my theta is equal to 71.57 degrees, okay? However, they want the general solution, and it's the tan ratio. So we know that this answer will repeat itself every 180 degrees, plus 180 k. Bear in mind that k is an integer. Okay, so let's just recap. So what did you have to do with this? You just had to, first of all, get rid of the root sign by squaring both sides, okay? And then you fold those two brackets out, you get that thing there, right? but they tell you that x squared over 1 plus x is equal to 1. So wherever you see that, just replace it with 1 immediately, and that's what we did in that step. So replace that bit with 1, as they say in the question, and we're left with those 2 1s. So if I add the 3 1s, we get 3. So that's what theta is equal to, shift tan of 3. Right. Let's just quickly go back to a question we left out because we didn't have the x values, and see how much of those we can do. Right, okay, we've found the values. Okay, so I know that that bit there, just the important points, it's 105 degrees. The last point there is negative 90 degrees. That one there is negative 75 degrees. So we're going up in 15s, as you can see. What do they say? Write down the values of A, B, P, and R. All right, so let's look then at A. Where's A? It's that one there. And which of the graphs is actually equal to cos? This graph here is equal to F, is the F graph, and this one here is the G graph. Right, so if I want to work out what A is equal to, if you look at this F graph here, it is actually the cos graph, okay? But it's been reflected over the x-axis. So that means that my A, which is the amplitude of my graph, instead of it being a positive number, it's going to be a negative. A negative what? That point there is negative 2. Okay, so my A is simply negative 2. What is B equal to? That number there. Okay, that is telling me how many complete waves there are in 360 degrees. So if we go back to our orange graph there, right, as you can see, this is not a complete wave. And if you work out from there to there, it is actually 270 degrees. If I were to continue this, it would finish, it would come to an end, okay, and that would be a complete wave, and that would take me 360 degrees. So it means that my B is equal to 1 because there is one complete wave in 360 degrees, right? And P, okay, P now will take us to the other graph, the sine graph. All right, again, P is the amplitude of my graph. So what is the distance from the center line to the highest point? As you can see, it is 1. So it means that my P value is equal to 1, and R, they want that one there. If I add something to that x, it means that the graph is shifting horizontally. All right? So how has this graph shifted? A normal sine graph would start there, right? But now this one doesn't. It starts there. It means it's shifted 45 degrees that way. Okay? So it means that my value of R is equal to negative. It's going to be equal to, going to be a positive 45 degrees because remember, it works in opposite directions. If the graph shifts to the left, the value of R is positive. All right, but that's about all we have time for. Okay, so I'm going to leave it there, grade 11s. And I'm hoping that as many of you as possible got the challenge question. AB, how did they do with the challenge question?
They did so well. Not all of them got it right, though. Some were still complaining that it was. Can you confirm the answer again for me? Okay.
Let's go back to our answer, our challenge question. Okay. 71,57 degrees.
Well done to all the mindsetters that got it right, including verbal underscore irony from Twitter. Thank you so much. Seth, thank you to you.
Thank you very much.
Till next time. Thanks to you guys for watching, and thanks to MTN SA Foundation for proudly sponsoring the show. Of course, the Department of Education, Basic Education, for endorsing this program. We love you and peace.